Hello, everybody. My name is Sean Morrissey. I am an electronics application engineer at Alpha Omega Product Development Systems. And in this video, I'm going to show you how to utilize your HPC license and why it is useful. HPC stands for High Performance Computing, and it allows you to run simultaneous design points, run larger models that require more memory, tackle longer transients and more complex physics in hours rather than in days of solve, which correlates to if you have more time, that means more simulation and better products. Or your HPC license allows you to reduce time and TCO with GPU computing. So you get the info you need faster by running multiple simulations in parallel. To get started with that, let's transfer over into our HFSS file. So let's say that you have your design here. Now this is just a Ansys example that's preloaded. If you go to File, Open Examples, I pulled the patch array from the HFSS file. You go to Antennas, and it is right here. In case you're curious, I would highly recommend, again, to explore these libraries as they're very helpful tools for you to learn and utilize from. However, outside of that, back to high performance computing, your HPC license. This provides enhanced engineering productivity by accelerating simulation throughput, enabling your engineers to consider more design ideas and make efficient product development decisions based on enhanced understanding of performance trade-offs. HPC enables higher fidelity insight into product performance that cannot be gained any other way. HPC allows engineers to simulate larger, more complex models so that the more accurate design decisions can be made throughout the development process. So we have our design here, and what you want to do is that you want to go to simulation, and you can see right here you have your HPC options. So after this window pops up, you want to make sure that you go to Edit, and you can edit your number of cores here. With my machine and my HPC license, I can have up to 12 cores, which has proven to be significantly helpful with the design process. A personal story I have with how important HPC is that I was helping a customer who had a very complex RFPCB model, and the simulation took about 30 hours bare minimum. They had just about, I believe it was 64 gigabytes of RAM on their workstation. So with no HPC and an older workstation, it took about 30 hours for the simulation to complete, for the mesh to fully be solved. And then they got a newer workstation with 128 gigabytes, and then that took them 22 hours without HPC for the simulation to complete. On my machine, utilizing the 12 cores and a machine not as powerful as theirs, it took me 12 hours. So even though the components of my computer were not up to par with what the newer workstation had, since I had HPC, I was able to cut their simulation down to 12 hours. And working with them to better optimize their file to make runtimes even faster. When they got their HPC license and they upped the number of cores, they were able to run that simulation from 22 hours down to 1 hour. So HPC dramatically helped their performance, as well as obviously updating their computer parts as well. HPC was their hero and provided the results they needed in a timely fashion. So, of course, multiprocessing speed increases with the number of cores that you have. Having 12 simulations can get done fairly quickly in this fashion. And also, that story is a very common story where users who don't have an HPC license have a free trial of it and see that their simulation run times decrease tenfold. It is a very very worthwhile license to get a hold of. And also, when you are in your HPC and analysis options, check your HPC license through the licensing portal. And if you don't see any improvement, just verify that you are using the correct license type. Because if it is not on the correct licensing type, then it will not work exactly how you may expect it to. And just to showcase, I am going to edit my number of cores down to 4. There we go, down to 4, and hit OK. And as you can see here, since it's a pre-made model, all I have to do is validate, and I'm going to analyze this model, and I will compare between utilizing 4 cores and then 12 cores. So here I'm going to hit Analyze All, Save, Yes. So we are going to open up a separate model here just because this one was giving me a few issues. Let's go with this helical antenna. There we go, nice helix antenna that was pre-made by Ansys. We're still on 4 cores. Let's go ahead and validate this. All right, close. Let us clear out all these messages and only have the helix antenna up and running. All right, we're going to analyze this, save it. No, here we're going to actually save this on my desktop. Okay. So while this runs, I will take note of the time, and I will be back once this completes. So this took about 6 minutes to complete, which again, this model isn't too geometrically complex, so may not be the best example. However, I believe it'll get the point across. So we do that, go to Analyze. To properly compare, I had to open up a newer instance of the file so that the results were already preloaded into that analysis. However, with the new file, this took 4 minutes as opposed to 6 minutes. So on this smaller scale, you can already see how HPC can improve your overall analysis time and how it is a very successful and efficient tool to use in order to help your engineers produce not only more accurate but also faster results, to be able to therefore get more results and more simulations done in a much quicker fashion. Thank you, and I hope you've enjoyed this video.